Alrighty, ladies and gentlemen, welcome back to the wonderful world of mathematics. Okay, we're moving on to 8.5 day 3, solving equations. Now we're going to be solving rational equations. Now rational just simply means fractional. Alright, so, let's take a look at this first one I've got here. Now this is the basic problem just to set the premise that we're going to work by here. Okay, now hopefully this is a very simple equation, although again the fractions might scare you at first, but if you look at this, x over 4 plus 3 over 4 equals 17 over 4, well, purposely without getting rid of the denominators for a second, I'm going to subtract 3/4 from both sides here, and I'm going to forget the fact that I could reduce what I'm about to get, but 17/4 minus 3/4 is going to give us 14/4, and then really if I just multiply both sides by 4, and you can see that the 4's will cancel here and cancel here and leave me x equals 14. Okay, now the point of this whole thing is if I look at this original equation and all these 4's, notice since they're the same, if I cross them out and just did this equation x plus 3 equals 17, notice using an algebra 1 skill here, I still get the same answer of 14. Okay, so basically I call this the duh principle. That if the denominator is the same, you can just throw them out and just work with your numerators. Kind of like it's so easy, duh, anybody can do it. Okay, but that's the premise we're going to work with to go with the more complicated ones. Alright, now here's an equation where clearly the denominators are not the same. I've got two that are similar but different because of the plus versus the minus, and then I've got a third term here that doesn't have any denominator at all. Of course, if you want to think of that as a 5 over 1, that might help things in a couple seconds. Okay, another thing with this problem before I go too much further is when I'm subtracting a fraction, okay, sometimes it's very, very awkward, and if you're familiar with the expression leave, change, change, maybe a decent idea here is to leave this guy alone, change that minus to a plus, and then put the negative sign up in the numerator. Okay, if there was more than one term here, I'd have to distribute that negative sign, but since there was only one term, I could just do that. Basically, I do this, it's not necessary, but I like to do this because that does solve some sign problems that some people run into. Alright, but here we go. Alright, now in order to make all the denominators the same like that previous problem, I want to make them all match so I can just throw them away. Probably the easiest way to go about it. Okay, so I've got an x plus 4, x minus 4, and effectively a 1. Okay, the way to make your denominators match is make sure they have all the same factors. So for instance, this guy on the left, he doesn't have an x minus 4. So I'm going to multiply the first fraction by x minus 4 top and bottom. Okay, the second fraction doesn't have the x plus 4. So likewise, he's going to get an x plus 4. Now this poor 5 over here, he's totally left out. He doesn't have either one of those. So he needs both an x plus 4 and an x minus 4. Okay, notice I'm using the parentheses here to stress the fact that we're multiplying. Okay, you may or may not want to write them there, but if it feels better for you, use parentheses around these guys here. And if it really, really feels good for you, show the parentheses right there for those guys as well. Whatever works best for you, as long as you understand what's going on. Okay, now we have kind of a mess to clean up. Okay, the x minus 4 gets multiplied by the 8x, so basically we have a distribution here. So I have an 8x squared minus 32x, and that's over my denominators of x minus 4 and x plus 4. Well, actually one denominator of the two factors. Alright, plus, okay, the negative 3 distributes here. I got a negative 3x squared. And then if you don't do the leave, change, change, a lot of people are going to give me a positive 12x here and end up making a mistake later, which is why I like to do what I did earlier, and this gives me a minus 12x. Okay, over the same two factors in the denominator, x minus 4, x plus 4. Alright, and then finally here, alright, well, I'll do the denominator first because that's easy. X plus 4, x minus 4. Notice I didn't bother multiplying them out in the denominator because I'm about to cancel them anyway, so who cares? In the numerator, though, I do need to multiply this mess out because I'm eventually going to have to do some combining like terms and things of that nature. So, what I recommend doing here is doing the FOIL first, and hopefully this is pretty easy FOIL here. That'll be x squared minus 16 because that's a difference of two squares factoring. And then once you've done that, distribute whatever the number was here into that. So I'm going to get myself a 5x squared minus 80 at that point. Okay, again, at this point the kind of duh principle takes over, and that if my denominators match, I can just throw them all the way out. So those guys disappear, and now I just have to work with the equation I'm left with in the numerators. Okay, on the left-hand side, I've got 8x squared minus 3x squared, which is a 5x squared. Okay, then I've got a minus 32x and a minus 12x, which is going to be a minus 44x. And that's going to equal 5x squared minus 80. Okay, so notice how this guy cleans himself up pretty quickly now. The 5x squareds can just cancel out, and I'm left with a negative 44x equals negative 80. Dividing through by my negative 44 is going to be x equals, and I'll do this in 2 steps for those of you who are fraction impaired. I've got negative 80 over negative 44. Alright, well, of course, I do want you to reduce that. The two negatives, of course, cancel out, and then I can divide the whole thing by 4, and I get 20 over 11. Okay, I got a little ahead of myself there. Be sure to check for extraneous solutions. Extraneous solutions are anything that would make the original denominators equal to 0, since we can't divide by 0. So basically 20 over 11, well, if I look at my original denominators, okay, a negative 4 would make this first guy equal to 0, positive 4 would make this second guy equal to 0, and this is clearly not either of those two numbers, so we get to keep them. If it was one of those two numbers, we'd have to throw it out. Alrighty, let's take a look at a little bit nastier one. Alright, so notice I've left a little bit of spaces here because there's something about to happen, but here we go. Alright, okay, notice I got an x minus 5 and x minus 7, so clearly nothing matches there. And then I've got this monstrosity here, which is a nice easily factorable trinomial, and by no coincidence whatsoever, it actually factors into x minus 5 and x minus 7. Okay, the two factors we have here. Alright, so basically this guy's got all of the factors that exist in this problem as far as the denominator goes. This guy doesn't have an x minus 5, so we need that top and bottom. Likewise, this guy doesn't have an x minus 7, so that's what he gets. Alright, now really at this point, if you want to, you could actually cancel out all the denominators and just worry about the numerators, which is honestly what I'm about to do. Okay, now it's important to identify again, like I said before, that these really have parentheses around them, whether or not you actually write them in. And so we're looking at here on the left is a FOIL. Alright, so foiling that, I get an x squared, then I get a negative 7 and a positive 2 with x's on them, so that gives me a negative 5x. And then the 7 times the 2 gives me a negative 14. Okay, again, I could write the denominator here, but I'm about to cross it off anyway, so why bother? Okay, I got a plus sign that just comes down here, and then I'm going to get an x squared, negative 3 and negative 5x's give me a negative 8x, and then I get a positive 15. And then the good news is nothing was happening over here, so I just have the x plus 17. Okay, so it's a little bit of a mess, but combining like terms cleans it up in a little bit of a hurry. So I get a 2x squared, I get a negative 13x, and then I get a positive 1, equaling that x plus 17. Okay, subtracting both of these terms on both sides, and just for clarity's sake, I'll actually show that here. Alright, so I'm looking at a 2x squared minus 14x minus 16 equals 0. Okay, now hopefully you can quickly identify that, hey, all those are multiples of 2, so you can do one of two things since you have an equation. Okay, you can factor out the 2, but since I have an equation, I prefer to divide by the 2 and just plain old get rid of it. So I'm going to divide everything by 2 here. Give me an x squared minus 7x minus 8 equals 0. Alrighty, so then that's somebody who factors pretty nicely. So I get an x plus 1 and an x minus 8 equaling 0. So that gives me answers of negative 1 and positive 8. Okay, though before I call them my final answer, I'm going to look at both of those individually and see if they make my denominator 0 in either case. So the negative 1 goes up here, nope, nope, and then notice the two factors are the same, so once I've checked these two, I've effectively checked the guy on the right. So negative 1 checks out, and again, quickly looking around, the 8 checks out as well. Again, the bad numbers would have been positive 5 or positive 7, because that would have made 0 denominators in either one of those two spots. But there it is. So I get two answers in this case. I get both negative 1 and positive 8. Alrighty, so here's our assignment. And as the note says on the bottom, it's short, so I know a couple of the previous assignments are kind of on the long side, so if you didn't manage to get sufficiently through those, this assignment should allow you a little bit of time to go back and pick up any pieces of anything you might have missed. Alright, of course, any questions? Ask me in class. I'll see you there.